About shortcuts to binomial multiplication. If you and I were to multiply x plus y to the fourth power, what it would be asking us to do is to multiply these binomials and these binomials and these binomials. And we're used to multiplying just two of these. If you multiplied this out, I think it ends up looking a little bit like this. But then you would take that guy and multiply it by this guy, and you'd get something else, and this guy, and off it goes into a huge, huge thing. And it's a lot of work, and it's hard to keep track of. So what I'm going to try and show you is a shortcut to learning how to multiply binomials by any power that we want, and we can come up with a solution very quickly without kind of all of the steps along the way. Let me show you how we can do that. Start by looking at some simple things. If you do a binomial to the 0th power, anything to the 0th power is 1. If you do anything to a power of 1, you get itself back, which would be 1x and 1y. Now when you do something squared, it takes us a little bit of work. I'll do it over here to see what happens. As you're aware, we multiply in a distributive manner. And so we would get x squared plus xy plus xy plus y squared. And that summarizes to 1x squared, 2xy's, and 1y squared. So let's bring that over here now. Now, what I want you to start to notice is a couple of things. There seems to be a bit of, I want to look at the patterns in terms of the numbers, the coefficients. And we see that kind of along this diagonal we get 1s, and along this diagonal we get 1s. And this 2 here seems to come from the connection of these guys here. For instance, if we were to do to the 3rd power, give me just a second to clean some of this off here. So we would get x plus 3 to the 3rd power. I won't multiply this out, but here is what we would get. And we're going to look to see if we can find a cool little pattern hiding in this here. So if we were to multiply this all out, this is be what we get. Now let's keep an eye on, again, the coefficients that are happening here. Notice, again, that 1 pattern is still continuing. Also, let's notice how this 3 seems to be connected to this 2 and the 1. To see how this 3 is created by the previous ones. So there's kind of this pattern going on. Let me see if I can show you the pattern I'm talking about. So the 1s along the edge, this would be a 4 because of these two. This would be a 6, this would be a 4, and this would be a 1. What can happen if you follow this pattern, you can continue to get all of the coefficients of these multiplications. They just go on and on and on and on and on and on and on, and they follow a pattern. There's also a pattern that's going on with the with the values that are in here in terms of, you know, x squared, xy, x squared, and so on. Let me just take a quick look at these patterns as well. What I want you to notice is, so in this case, you've got x squared, and then an x and a 1. Notice an x1 and a y1 add to 2. Here's x2. So they split the value, but they come to 2 together, and then y to the 2. Here you've got 3. 2 and 1 is 3. 1 and 2 is 3, and then 3. So they always will sum to the power of that particular one. The other thing that happens is you can kind of see the x counts down. 3, 2, 1, none. And you can see y does the reverse. 3, 2, 1, none. So if I was to do this, this would be x to the 4th. then it would count down to the 3, to the 2, to the 1, and none. Going the other way, you would go y to the 4, y to the 3, y to the 2, y to the 1, y to the none. This would be the multiplication of all of those of x plus y to the fourth. X plus y to the fourth would become this. If I wanted to do to the fifth power, it would be to the fifth, and then to the fourth, and then to the third, and then to the second, and then to the one, and then to the none. Then I'd go the other way, y to the fifth, y to the fourth, y to the third, y squared, and y. And again, amazingly enough, what could have, should have taken, I don't know, minutes, hours, half an hour to do, you and I were able to basically multiply out a huge multiplication statement and get it all kind of tightened up into one place. Let me just show you one more example of this in a clearer sheet here. So here's the idea. If I multiply an x plus y to the fourth, one thing I know is I can quickly create my little triangle, what's called a Pascal's triangle, and that can help me obtain my lead coefficients. So I know that there's a 1 here. Then I also know that it's going to start with to the maximum, to the fourth power. Then the next coefficient's a 4. I know that this will come down 1, but I introduce the y value. Then I see the next coefficient 6. My x value comes down, my y value increases. My value for x, for my coefficient is 4, my value of x decreases, my value of y increases. And then finally, here I am. This is the multiplication of all of those pieces out, gathered and organized in a nice little way. Let me just do 2 more examples to just keep showing you how this works. So let's take a look at this one. Something happened here that's a little bit different that I want to make sure you notice. Is instead of x plus y to the third, it's x plus 3. Or in other words, the y value from this point on will be a 3. So let's multiply this binomial out. Now you and I know to start with our Pascal's triangle, and this becomes our set of coefficients. So let's do that. 1 x to the 3, no y value, then 3x squared y, then 3x y squared, and then 1y cubed. Now, the next thing we have to do, that isn't our answer because remember, there isn't a y there, it's a 3. So wherever we see a y value, we're going to plug in brackets, a 3. So I'm going to plug in a 3 here. And then I'm going to do 3x and a 3 squared there, and a 1 times a 3 cubed there. And then I just do the math. This is still 1x cubed. 3 times 3 is 9. 9 times 3 is 27. And 3 times 3 times 3 is also 27. This is the multiplication of x plus 3 all cubed. And where are the y's and those types of things? Well, again, that idea is wherever we saw y, we put in the value of a 3 because that's what it was. Let's do another one of those to show you how to do it. All right, this one can be a quick one. We're only squaring something, so when we make the Pascal triangle, we just get to this point and we have our coefficients. So we know that it would go x squared, and then it would go 2 would be the coefficient, and an xy, and then a 1y squared would be the arrangement. But we notice that the y is a negative. So wherever we see a y value, we're going to plug in, and I always use a bracket set because that's very important, and a negative 2 here. And so our final answer becomes minus 4x plus 4. Now again, just to make sure you're clear of what I did, is wherever I saw the y value, I plugged it in. and then simplify the arrangement. I'm going to do one last one, and it's a little bit different, and so I want to make sure you have an example of it as well. All right, the last one, you'll notice a couple things are different. There's a number in front of the x this time as well. So I want to think of wherever I'm going to have an x, I'm going to plug in a 2x instead of just a single x. And wherever I see a y, I'm going to put in a 3. All right, so I quickly made my Pascal's triangle. 1, 3, 1 are the numbers. So again, I'm just going to create the basic scenario of my setup. I use the 1, 3, 1. I count down on the x's, count up on the y values. This is what it looks like. Now, I'm going to substitute in where I see an x, a 2x, so 2x cubed plus 3 times 2x squared, and the y value is a 3 this time. And then I'm going to have my 3 times x, and x is a 2x, and my y is a 3 squared. And then I have 1 times 3 cubed. Let me make sure that that's clear to you what I did. Wherever I saw an x, I plugged in a 2x. Wherever I saw a y value, like here, I plugged in my 3. And now I just need to simplify. So 2x cubed is 8x cubed, because 2 times 2 times 2 is 8. Now in the next case, I have a 3. I have a 3, that's 9, and this is 4, so that's 9 times 4 is 36x squared. In the next case, I have a 3 squared, that's 9, and then 2 times 3 is 6. 9 times 6 is 54. And then in the last case, I have 3 cubed, which is 27. So again, you have to be a little tricky in each of these cases, because you have to kind of, especially with the 2x being in the brackets, 2x cubed is 8x cubed, and 2x squared is 4x squared, and 4 times 9 is 36, and so on. Hopefully this will help you out.